Okay, so the next one we have here is a guessing the number, which will pick a number, between 0 and 1. Again, this is how games work, and it'll prompt you to guess a number. So there's a guess number one time and guess number. It just provides an extra line. Yeah, that's it. Stacy, print line just provides an extra line. That's all it does. So yeah, nothing big there. And these commands actually go back to the C language, which has had a printf, print, and print line commands as well. So just something it adopted from there. So we have guess number one time. Now in this case, guess number is using a method of the math class called random and multiplying it by 101. Math.random is basically doing exactly what we did in the last example with getting the milliseconds. It's basically doing that. It may be doing something, it may be doing it a little more efficiently, but it's basically doing what we did. And it's generally the preferred way of creating a random number. So now remember that math.random is going to generate a number somewhere between 0 and 9. So if you multiply that number by 101, multiply 99 by 101, you get, I'm sorry, if you multiply 9 by 101, you get, oh no, excuse me. Random is going to generate a number somewhere between 0.1 and 0.9. Is that correct? Yes, that's correct. So 0.9 times 101 would be 99, I believe. Is that right? Yes, 99. Well, actually, no, it wouldn't be. It would be 91. How does that work? Random, what's random generate? It's an integer. It would be 0 to 0.9. 0.1 to 0.9. Let's run this and see what we get. So guess a number between 0 and 100. I'm wondering if this is correct. Alright. Let's run it. That doesn't quite look right. Let's see what happens. Enter your guess and prompt them. If the number equals the guess, say yes, the number is that number. Otherwise, it's too high or too low. So we're going to let him know whether it's too high or too low. And I don't know what the number is. I'll say 55. Your guess is too high. Now, the problem is it only ran once. So that's a problem. So how would we convert this to make it keep going until we guess the right number? So we'd have to convert this, probably change the if to a while loop. Say while, we probably would say they're not equal. And we'll put this at the end of the while, actually. Because if they get here, that means they guessed the number right. We don't need that. So okay, so that should work, I think. And it's simply going to say, while the guess is not equal to the number, it's going to say it's either too high or too low. Of course, then we need to prompt them to re-enter the number. Otherwise, does anyone know what would happen? Yes, it should be in curly brackets. And we just want to do this again. Okay. This should work. I'll go ahead and run it. Enter your guess. So I'll say 55 again. It says your guess is too low, and it prompts me to enter again. So if I say 65, it says my guess is now too high. So I know it's somewhere between 55 and 65. So I'll just say 60. Your guess is too low, so now we know it's between 65 and 60. Let's try 63. Your guess is too low. Well, it's got to be 64 then, right? Yep, number 64. And then the program terminates. So the while loop basically keeps you in the program until you guess the right number. And did I have any questions on that example? I know some people said I was going too fast last time. I'll try not to. The math subtraction learning tool program generates just one question for each run. You can use a loop to generate questions repeatedly. This example gives you a program that generates 5 questions and reports the number of the correct answers after a student answers all 5 questions. So I think you all have access to these programs, and you should be trying them on your own. Well, this one's kind of ugly. Here is an example of a constant. Remember, if we talked about constants, that they would be final, and the variable would usually be uppercase. Final means it's read-only. You cannot change it. And the value is 5. And then the number of questions, which is the constant name, would be uppercase. The rest of these are regular variables, integers meaning whole numbers only. Remember from data types. We've got correct count and count, which will count the number of questions, and correct count will count the number of correct answers. And again, it looks like we are going to get the time in milliseconds, the scanner, and while the count is less than the number of questions, so it's going to ask again 10 times. The 2 numbers is going to use the random number generator again. You got it? And if number 1 is less than number 2, swap the 2 numbers. Oh, that's so that we don't get negative numbers. And then it's going to say, what is these again? And again, we could rewrite this, because this is kind of ugly. So if we wanted to rewrite it using the printf statement, I could do that. And then this would just become percent %d minus percent %d, and be number 1, number 2. All right. And it says, okay, well, if they're correct, it gives you this one that says they're correct. Otherwise, it tells you, no, you're wrong. You can't do basic subtraction. Counts the number, and then it also counts the number correct here by adding 1 to correct count, and adds 1 to count here. And this thing is building an output statement telling you basically how you answer what was correct, what was wrong. This final output is going to tell you the correct count, how long it took you to take the whole thing, and the output. So we could probably write this a little better, but Let's just run it and see what we get. Okay, what is 7 minus? It's going to be 2. 2 minus 0 is 2 again. Oh, look at that. 9 minus 1 is 8. And is that 8 minus 8 would be 0. 7 minus 6. I'm going to get 1 wrong. Say 2. So then we get the output, and it says what each one was and whether it's correct or wrong. So, and then you can run it again. You can do it as many times as you want. We certainly could make this a little cleaner by getting rid of all these things and using printfs. That certainly would definitely be better. So after this, I can say %d minus %d should be %d. So here you'll notice I'm putting a \n because it replaced a printl. And so, okay, so these numbers are simply going to be okay. So that would work a little nicer. You can see it certainly looks more readable. You could do the similar thing with the output. This could all be redone with a printf, so it'd be a little more readable. Questions on this example? So yeah, we could clean this up a little bit more, which probably would be helpful. Correct answer is %d, and then we have \n. Test time is %d again in seconds, and now output would be a string, so we would say %s. Then here, do all that. And that would be that. Actually, that. Oops. Printf. And we'd have to put a \n here. And we could run this, and it should give us the same answer. 9 minus 9 is 0. 2 minus 1 is 1. 5. 8 minus 8 is 0. 2. And there. So we get the same output. It's just a little cleaner using those printfs. All right. Any questions? And I hope that answers the question about printf versus print line.